So you've learnt most of the skills that you need so far in probability. One of the most important skills from probability was conditional probability. So if you haven't practiced that, that should be one of the ones because I haven't got many submissions for it yet. But that is the key skill that you should be taking in. So conditional probability, which leads into independent events. Those are the two key things to take away. The rest, for example, this exercise is only revision. So these are stuff that pretty much year 8, year 9, year 10 will repeat the same skills. Even year 11, they still repeat these skills. And then year 12, we kind of take it as a prereq knowledge. So let's start off with this one. Example 1, boxes A and B contain 5 counters each. So I'm going to draw a picture just so that we can picture it. Box A, box B. They each hold 5 counters. Box A has 3 red and 2 greens. So I'll write here 3 red, 2 greens. Whereas box B contains 1 red and 4 greens. A box is chosen at random, so that's key. Sometimes if they could say 2 boxes are chosen at random, which that will make a different case scenario. But it says a box is chosen at random and then a single counter is selected. So, if box A is chosen, what is the probability that a red counter is chosen from it? So this is a pretty straightforward scenario because it's only 1 box is chosen. So if it's 1 box, you can either get A or you can get B. If you chose A, you could get either a red or you can get a green. If you chose B, you could get red or you can get a green. Can you see how I'm sort of using a tree diagram to illustrate the scenario? So there's 2 choices. You have to pick a box, and after you pick a box, you have to then pick a counter. Now, the chances of getting red in box A, well, there's out of 5. They're all out of 5. But if I chose box A, what's the chances of getting red from box A? Let's go with Toby. What's the chance of getting a red counter from box A? How many red counters are there?
3 out of 5.
3 out of 5. Very good. There are 3 reds, so 3 out of 5. And then obviously the leftover is green, which is 2. So you get 2 out of 5 in getting green. And so if we answer the question now, it says, if box A is chosen, what is the probability that a red counter is chosen? We would say the probability, and this is where it's, you got to be careful here. The question, sometimes they say, what's the chance of picking a box A and then choosing a red counter? In that case, you have to take into account of the probability of A. This one is saying if box A is chosen, so that's something that we already know has happened. We've got box A already, and within that realm, what is the probability that a red counter is chosen? So really, technically, this is saying, what is the probability of getting a red counter given that A is chosen? Okay. In this case here, conditional probability, what was the rule again? What was the rule for this conditional probability? Let's go with Olivia. Do you remember the rule for what's the chance of getting red given that A had already occurred?
Probability of a intersection B.
Ooh, close, not B.
Oh.
Oh, you're telling me the rule
Oh,
for this scenario.
R.
Good. So it would be R intersecting with A or A intersecting with R over? Very good. Probability of A. Because A is what has happened. So we're looking at the scenario of A. Now in this particular scenario then, what's the chances of R and A occurring? Well, if we look at it, what's the chances of picking box A? Logically. 1 out of 2, because there's only 2 boxes, and they never said whether you're more likely to get A or B, so we're assuming it's equal chances of picking A or B. So it's 1 out of 2. So if we put it together, probability of R intersection A is only this branch. So that means the probability of getting R and A simultaneously, so picking A and choosing getting the chance of getting a red counter, is half multiplied by 3/5. Okay? And that will again give you 3/10. So that means you've got a 30% chance overall. So that's 3/10 in the numerator, divided by the chances of getting A, which we already know. Chances of getting A was only half. So it should be 1 out of 2. And then from here, we just got to practice a bit of fractions. What's 3/10 divided by 1/2, Jaden? 6/10. That's correct. 6/10. For those who aren't sure on how to do that, if you just wrote 3/10 and you wrote out what you saw, so 3/10 divided by 1/2, we know that with fractions you do the reciprocal, so there should be 3/10 multiplied to 2 times 1. That's how Jaden got 6/10. Okay? All right. Doing similarly, I'm going to pause the video. You're going to try the next one. If box B is chosen, what is the probability that a red counter is chosen from it? I'm going to pause the video. Missed a whole lot of recording, so you may, if you're watching this now, you may want to just copy the answers. Pause, copy, pause, copy. All right, we're up to number 3, exactly 1 blue marble. So let's have a look at our tree diagram. To get exactly 1 blue marble, which options can you see? Can I please have Sean? Very good. So chances of exactly 1, you can only get either a blue on the first go and then a white on the second. Or, and so when you say or, notice I'm doing a plus now, you could have had another scenario. It could be white first and then blue. So working out each one, we already got B and W. What we're missing is W and B. And we can see that's 5/9 times 4/8. So here, I'm just going to write in the answer 4/9. Is it 4/9 or 5/9? 5/9. 5/9. 4/8. Plus probability B and W, we found it was 5/18 previously. So let's put it together. So you got 5/18 plus, what can we simplify here? Nothing there. So 5 times 4, 20/72. That's nasty. Can I simplify anything? Oh, I could have simplified the 4 and the 8, actually. Half. Whoops. 5/18. Haha. And that gives you 10/18. 10/18 is the same thing as 5/9. So you got 5/9 of a chance of getting 1 blue marble. Exactly 1 blue marble. And let's go to the last question. If the experiment is repeated with replacement, find the answers to each part of the questions. Now, in this scenario, I'm going to end it at this point here because you probably can't do it. But what I'm interested in is because this actually links into binomial distribution. So when it's repeated, I'm wondering if you can figure out a rule for it. See if you can find the pattern. I'll write the rule at the end. You don't have to know it. If you figure it out, great. If you figure it out and you think you're unsure, come to me and I'll confirm if it's true. But in this scenario, if you have blue, white, and we said it was 4/9, 5/9. If it's with replacement, you'll get blue, white, and again it's 4/9, 5/9, 4/9, 5/9. I want you to figure out, as you're doing these questions, if we followed up and I did 3, 4, or 5 branches. There has to be a quicker way to solve, and because it's repeated, there is a pattern to it. So I want you to first find what's the probability of getting blue, let's go with blue and white, just so that it links back to this one. Then, so that's with 2 marbles, yeah? Then in the second scenario, I want you to find the chances. What if I did 3 marbles now? So 3 marbles, what's the chances of getting blue and white and then white? So this is 3 marbles. Then I'm going to go to now 4 marbles. Blue, white, and white. Whoops. And white. So if you can, hopefully at this point, you may start to see a pattern. This is probably going to be the longest one to do. So if you got 3 whites and 1 blue, because you'll find that that's not the only scenario. You may not need to do this one, but if it does help you, by doing that last one may help you figure it out. Find me a rule. Find me a rule that if I did, say, 99, or I shouldn't do 99, let's do 10. Let's do 10 marbles. What's the chances of getting 1 blue and 9 whites? So I'm going to write on the side here, this is 10 marble scenario. This is 4 marble scenario. You should be able to figure out the rule with 3 marble scenario. Okay? And if you want to not do 4 and 10, because 4 and 10 makes it really crazy, one way is to draw out the full tree diagram for 3. Draw the full tree diagram. And if you looked at for each probability, so we did all 3, so you did 3, 3, fill out all the probabilities and actually calculate 1, 2, 3, 4, 5, 6, 7, 8. You should be able to pick up a pattern if you did 3. So if you drew 3 branches, first marble, second marble, third marble, worked out has B, 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 W, B, W, B, B, W, B, WBB, WBW, WWB, WWW. You will then be able to see, work out chances of getting 1 blue, 1 white, 2 blues, 1 white, and then 3 blues. There should be a pattern that pops up. And if you can, then you should be able to predict or use a way to make a formula. If you can do that, that's how I usually teach my year 11s. I get them through a worksheet, and I do this with them. I do a 3 branch tree diagram, and then they should be able to see the formula, but that's called binomial. Binomial distribution. So if you wanted to cheat, or not cheat, but more like if you just want to jump to the answers, if you typed in binomial distribution formula, there is a way, and it only works if all the probabilities are consistent. Okay, so that's what I'm teaching my year 11s this term. It's one of the studies for year 12, but it starts here. It starts with understanding the difference between with replacement without. Do you need to know it for your exams? No. This is just me extending you for those who are interested in delving a bit deeper with probability. Okay, otherwise, that's it for today. All right, I'm going to stop the video.